this video, we will be discussing about maximum ascending subarray sum. Given an array of positive integers nums, return the maximum possible sum of an ascending subarray in nums. In the input, we are given an integer array nums. We need to find out that what is the maximum sum of an ascending subarray. Right? First of all, what is a subarray? A subarray is a continuous set of numbers from an array, right? So basically 10, 20, 30, this is a subarray. 20, 35, this is a subarray. 5, this is a subarray. But 10, 20, 50, this is not a subarray because the numbers are not continuous in the array, right? Now, wherever we have ascending subarray meaning in that subarray, all the numbers are sorted in ascending order. And for those subarrays, we need to find out that what is the maximum sum. For example, if we look in this particular case, we have 10, then we have 20. This is in ascending order. Then we have 30, again ascending order. And then we have 5. So basically, this much part is in ascending order. What is its sum? Its sum is 60, right? Then if we find some other ascending subarray, so we see 5, 10, 50. This is also an ascending subarray. Its sum is 65. So the greater sum is 65. So this is our answer. Okay. Now, how are we going to solve this? So the brute force approach would be to consider all the possible subarrays of this array. And that how can you consider? So you can consider each of the element in the nums as the starting element of your subarray, and then you can keep on checking from the next element whether they are in ascending order or not, right? So basically, first of all, you can keep I over here, and then inside that you can run a for loop of j, which will start from the next element, right? So basically, your sum at this point would be 10, and then you would start your j from here, right? And then you will compare the jth element with the previous element, right? Basically, you will compare that nums of j. This has to be greater than nums of j minus 1, right? If it is, then you will update the sum. So it will become 30 and you will move your j forward. So it will come here. Again, the condition is true. So you will update your sum. So it will become 60 now. Then j will come here. Now the condition is not true. So as soon as the condition is not true, we will break out of this jth loop, and in some variable where we are tracking the maximum sum, there we will take the max of the maximum sum and this particular sum, right? And then we will move our I over here, and then we will start j from here, and this we can do for all the elements in the nums array, and we will be able to identify the maximum sum, right? But now here first you would be running a for loop of I from 0 to n, and then a for loop of j from I plus 1 to n, right? So it will be n square. Now the constraints are very small, so n square will also work, but let us try to see the optimized approach as well. So see, if I am at this particular point and I'm checking the next element, basically at each point I am comparing the adjacent elements. So see, right now initially I can keep my sum equals to the first element, which is 10, because see, every element, every individual element is an ascending subarray, right? So initially we can keep the sum as this, and we can start our loop of I from here, right? And then we can compare the ith element with the previous element. If they are in ascending order, then what we can do is we can update the sum. We can add this ith element into the sum, right? So sum will become 30. Then I will come here. Again, we will compare 30 with 20. So they are in ascending order. So we will update the sum. Sum will become 60. Then I will come here. Now the condition is not true. Now they are not in increasing order. So what we will do is that in the variable where we are tracking the maximum sum, we can take the max of this sum, right? Basically, we can take a maxi variable and initialize it to 0. In this, we will put the max of maxi comma this particular sum. So this will get updated to 60, right? And now since here the condition was not satisfied, then that means a new subarray will be started from this particular point, right? So what we will do is that we will update this sum to 0 now, right? And then we will follow the same process and we will keep on updating this maxi variable, and at the end we can just return it, right? So here we will be iterating just once in the nums array. So our time complexity will be order of n, and we won't be taking any extra space. So space will be constant. So now let's try to look at the code of both the approaches. So this is the brute force approach code. Firstly, we have taken a variable maxi to keep track of the maximum sum, then a variable sum which is initialized with 0 to track the sum of the current subarray, and then we have taken the size of nums vector in n. Then we are running a for loop of I starting from 0 going till n. We are updating the sum with nums of I. Then we are running a for loop of j starting from I plus 1 and going till n. And then we are checking that if nums of j is greater than nums of j minus 1, meaning the elements are in ascending order, then in this sum, we are adding the value of nums of j, right? And if this condition is not true, then that means they are not in ascending order. So we are breaking out of the loop. When we come out of the loop, we are updating our maximum sum with the max of maxi comma sum. And at the end, we are returning this maxi. So let's run this. Now, as I said, here we are running a for loop n times. Here also we are running a for loop n times. So here the time complexity is n square and the space complexity is constant. So now let's try to write the optimized approach code. So first of all, let's take a variable maxi, initialize it to 0. And then we can take a variable sum, and in this we will keep the first element of the nums, right? And then we will run a for loop of I starting from 1. Since we are starting from 1, that is the reason we have initialized the sum with the first element. And then I less than nums dot size, and then I plus plus. Now inside this, what is the ideal condition? That nums of I should be greater than nums of I minus 1, which is the previous element, right? So we want the false condition. So that will be that nums of I, if it is less than equals to nums of I minus 1, that means they are not in ascending order. So if this is the case, then what we will do is that in the maxi, we will update it to the maximum of sum comma maxi, and then we will initialize sum to 0, and outside of it in the sum, we will always add nums of I. Right? So what will happen is that whenever the condition is true, basically this particular line will be executed every time. So till the condition is true, the element will keep on adding into the sum. As soon as the condition becomes false, it will go inside this if condition, and whatever is the sum, it will update it, right? And then the sum will become 0. And when you will come outside of this if condition, then whatever is the current element, that will be added into the sum, right? And then over here, what are we going to return? We cannot just return maxi. Why? Because let's suppose that the ascending subarray is ending at the last element. Then in that case, whatever is the sum, that won't be updated into the maxi. Basically, this particular condition will not run, right? So here also we will have to return the max of maxi comma sum, right? This is what we need to do. Let's try to run this code. Here we are running a for loop only once in the nums vector. So the time complexity here is order of n. Let's submit this now. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.